Okay, welcome back to some more pre-calculus fun. In this video, we are going to look specifically at trigonometric functions in terms of angles and rotation. So essentially what we're doing is we are going to start entering into the pre-calculus world where you're going to be drawing your right triangle in order to figure out the trig function you have to use in order to solve your problem. So in order to get that, we kind of have to know what some of that looks like. So as a reminder, when we are talking about angles and rotation, we are talking in reference to what's called the unit circle, or we're talking about in reference to rotating around a circle, and we use a coordinate plane in order to do just that. Now we have to be able to create your angle in what we like to call standard position, and so to do that means we have to use the initial side, or your first ray, and usually that goes along your x-axis. Standard position means the x-axis is in the positive direction, and then your second ray, or the terminal side, would be where your angle is. So it would appear in one of the four quadrants, either in a positive rotation or a negative rotation. Okay, so we use that idea and we slap trig functions into it. So we have trig functions of angles or rotations. So first of all, we have to be able to create your right triangle. You're going to make sure that your vertex for your triangle occurs at the origin and that the other one occurs on your x-axis. Okay, so I have four quadrants here, so we're going to put a triangle in each quadrant so that you can see how that looks. So first and foremost, let's put a quadrant here in, or a triangle here in quadrant 1. So to do that, says again, I'm going to make sure my vertex occurs at the origin, and then I'm going to draw in what's called your radius, but basically it's your straight line that goes out to your triangle itself. Okay. Now with that, to drop in your triangle, you would drop in your dotted line. It's going to come straight down there to your x-axis, and you can see here would be your triangle. So your 90 degree would occur right here. Your angle is always going to occur at the angle closest to your origin. However, depending on what your triangle is, you may shift that angle around, but mostly we like to use the one closest to the origin here. So the straight line is going to be your radius, which we always label with an R, and then in terms of your coordinate points, your horizontal is your x-axis and your dotted line here is your y. So what that means is that your first, or your one vertex, this point down here, occurs at the origin, so this is the point 0, 0. Your other one is going to occur here at the point x, y. Now we use that idea in order to solve for trig, but that is your first triangle. Now let's look at what happens if we put our triangle here in the second quadrant. Again, we're going to start at the origin. Again, you're going to draw yourself your straight line that goes straight out to your triangle, and you're going to drop in your dotted line. So again, there is your 90 reference. Your theta goes close to your origin here, so this is still the point 0, 0. And then if we look, this is still going to be my radius, but now if you look at your value, this is a negative x, and this would still be y. So in terms of the point, what's changed is that this is now at the point negative x, y. Okay, so notice we've got a little slight change there. Now let's look at my third quadrant. So your third quadrant is the one that's down here in the bottom. Again, we're starting at the origin. Again, we're going to draw our lines straight out to our circle, but we always want to drop your dotted line to the x-axis, not the y-axis. So this is going to form my 90. So again, we have the point 0, 0 at our origin. The solid line is your radius. Notice I have a negative x distance, and this time I have a negative y distance. Makes my outer circle point negative x, negative y. Now the last one that we have is we have the fourth quadrant. So that's going to be my fourth quadrant over here. So again, we're going to start at the origin, 0, 0. And in this case, we're going to draw our line. You know, we're going to come straight out, just like we've done with the other three. You're going to drop your dotted line to the x-axis. So there's your 90. You're still at the point 0, 0 for your origin. My solid line is still the r, but in this case I have a positive x and a negative y. So thus making my coordinate point here x, negative y. So those are the four quadrants and how your triangles are going to look, act, and be in those four quadrants. Now, as an aside, there's an important thing that we have to remember when we're working, and we need to recall the following. So, recall your reference, that when we're talking about the sine of your angle in terms of your triangle here, the sine of your angle is always opposite over hypotenuse. And so in this case, in reference to my first circle, my sine is going to be y over r. It means my cosine of my angle is going to be x over r. And it means my tangent of the angle is going to be y over x. So we can take each of these circles and you could create or relate your trig functions to each of them, which is actually where we are headed. Okay, so let's look at what we can do next. Well, once you identify kind of and are comfortable with your triangles, you have to be able to look at what's called a reference angle, or your reference triangle, which is exactly what we did. It's the triangle that can be drawn inside a quadrant where its one side, or the initial side, is always falling alongside the x-axis, and your terminal side is always located within the quadrant. Now, where you draw your reference angle or triangle is going to help determine the sine of your trig function. So we have kind of a little chart or a little saying that we like to use in order to help out. So if we look at our coordinate plane here, our little saying is going to state that all students take calculus. Now, out of that saying, there's only a certain part that we pay attention to. A, S, T, C. Now, when we start labeling these quadrants here, what you have to remember is that you are essentially drawing a C. So when we do that, we start with all students take calculus. Now, A stands for all. So this is all trigs. And we're looking at what is positive. Okay, so this is all of them are positive. Now, S is standing for your sine, which also means your cosine is positive in the second quadrant. Now, we've got tangent for t. So this is your tangent, and your cotangent is in the third quadrant. Your fourth quadrant is going to be your cosine and your secant, which again, remember, is the opposite of cosine. So all students take calculus. All students take calculus. ASTC tells you where you have positive. So we can use this idea. So this problem here, this first problem, says that you need to find the 6 trigonometry functions and the values for the angle shown. And the angle is 305 degrees. So first and foremost, we need to draw ourselves our triangle. So we're going to put in our coordinate here. We know that we start with 0, we end with 360. And we also know up at the top is 90. Over on the side is 180. Down to the bottom is 270. So we want 305. So 305 is going to be roughly down in this quadrant. So we can draw in our reference triangle, and you can put in your theta here. Now what we know is we know that from 0 wrapping around to here was 305 degrees. So if I wanted to actually know what my little theta was going to be, I would have to take 360 minus the 305. So I could do a couple things. One, you could run that calculation just in case you need it, or double check your problem. In this problem, all we want to do is find the trig functions. Once you know what your angle is, you should have a general idea of which trig functions are going to be positive. I'm in the fourth quadrant here, which says my only positive trig functions should be cosine and my secant. Everything else should be negative. Therefore, what do I know? Well, first I know that I have to take sine of my angle. So in this case, I am going to look at sine of 305 because that is my angle. And the sine of 305 you would do on your calculator. So let me kind of rearrange here so you could see it. Here's your calculator. Again, of course, I'm using the TI-84 Plus, so if your graphing calculator is slightly different, your directions may be slightly different. For this calculator, we've got sine, cosine, tangent right here. So what I would do is I would hit the sine button, and then because I want the angle of 305, let me move this over a little bit more, we would punch in 305, close it, and hit enter. And notice it comes out with a negative value, which is what we would expect. So here we would have negative 0.8192. Now the next one I have to do is cosine. So I have the cosine of my angle is going to be the cosine of 305. Again, you can click your cosine, type in 305, close it, and hit enter. Notice it's positive, which is what we should have expected. So here this is 0.5736. And then I have tangent of my angle. So that's going to be the tangent of 305. So we would hit tangent 305, close it, hit enter, and we get negative 1.4281. Now we have to do the little 3 or the minor 3. So the first one we have is we have cosecant of my angle. Well, we have to remember that cosecant is the same as 1 over the sine of your angle. So in this case, we would have 1 over the sine of 305. So 1 divided by, and then sine of 305, close it, hit enter, and there we have it, negative 1.2208. Now some advanced calculators or heavy duty calculators actually have the cosecant, secant, and cotangent buttons as well, but most of them don't. We have to end up using the reciprocals of them. So just keep that in mind when working your calculations here. Now the next one we have is secant. So remember, secant is the same as 1 over the cosine. So this would be 1 over that cosine of 305. So 1 divided by cosine 305, which is going to give you 1.7434. And then last we have cotangent of my angle, which is 1 over the tangent. So this is 1 over the tangent of 305. So again, you would do it on your calculator. So negative 0.7002. And for a problem like this, that's really all that there is to it. Okay, so once you have a good idea on where your angle goes and what you're doing and what quadrant you're in, you know which values are positive and which values are negative. It's a good way of being able to double check your work. Now in this next problem, it says find the 6 trig function values for the angle shown. And in this case, instead of giving an angle, we're giving you a coordinate point. So we're saying this is up at the point here. Okay. And so when we are talking about our triangle, we would drop our triangle down to the x-axis. So in this case, what we are actually talking about is we would be talking about going from here in the reverse as being, say, your angle here. And so this is what we're doing. So we might call this angle beta. Now, when we're looking at this, what do we actually know? Well, this point here is telling us all the information we need. It tells us that my x value is going to be negative 2. So this is negative 2. And it says my y value is 11. And then I have my radius here. So you have to use Pythagorean's theorem to find your radius. So we know a squared plus b squared equals my radius squared. So with that, I've got negative 2 squared plus 11 squared equals r squared. So here we're going to have 4 plus 121 equals r squared. So r is going to give you the square root of 125. So when we do that, we end up with that r is going to be 5 square roots of 5. So that's what goes right here. This is 5 square root of 5. So once you know that, now again, we can find our functions. And we use that because we need to remember that we knew that, say, the sine of your angle was equal to y over your radius. So we're going to take this idea and we're going to apply it. We're going to apply it using your angle down there. So we have the sine of my angle is going to be opposite, which is 11 over the radius, 5 square roots of 5. You need to rationalize. Remember, you can't have radicals in the bottom, so you would multiply top and bottom by the square root of 5. So this is going to give you 11 square roots of 5 all over 25. Now you need to do the cosine. The cosine of my angle is going to be negative 2 over 5 square roots of 5. again, you're going to rationalize, which is going to give you negative 2 square roots of 5 all over 25. Now do your tangent. So the tangent of my angle is going to be negative 11 over 2. Now we need to do the opposite. So we have the cosecant of your angle is going to be 1 over the sine of your angle, which essentially means take the sine of your angle and flip its reciprocal. So this is going to be 5 square roots of 5 over 11. Your secant is going to be the same. It's 1 over the cosine. So go back to your cosine and you're going to flip its reciprocal. So this is still going to be negative, and it's going to be 5 square roots of 5 over 2. Last, we have your cotangent of your angle, which is going to be 1 over the tangent. So go back to your tangent, and again we're going to flip its reciprocal, negative 2 over 11. Now if you look at it, this triangle ended up being in the second quadrant. So the second quadrant says that both of my sine functions should be positive. So if we look, the sine of my angle is positive, but my cosine and tangent were negative. My cosecant was positive, but the secant and cotangent were negative. Okay, so it's a good way again to double check yourself by remembering all students take calculus. Alright, let's look at a couple other examples here just to make sure that we all understand. So, in this example, I'm giving you that the terminal side of the angle is in standard position and lies on the given line for the given quadrant. And you need to find sine, cosine, and tangent. So I'm telling you that 2x plus 3y equals 0 is the equation of your line. And you're talking only about quadrant 4. So the first thing that you need to do is you need to figure out what your line is. So I have 2x plus 3y equals 0. And here I need to solve for y, because I need to find out my linear line. So I'm going to subtract my 2x, divide by 3. You end up with y is going to be negative 2/3 x. And so I'm going to go ahead and graph that. So you're going to draw out your quadrant. And so we have negative 2/3. So you could start at the point 0, 0. So we can start right here. And then anything else you turn in, you've got a negative slope. So down 2 over 3. And so we're going to use our ruler. And that would say put it, say, roughly here. So we've got this line that I just kind of dotted in. Now, with that, we were told very specifically a quadrant that we had to use. And we are supposed to use quadrant 4. Which means when we look at this, we don't care about the part up here in quadrant 2, we only care about it in quadrant 4. So this is the side that we care the most, so I would go ahead and draw that in, which means we can drop in our line, put your theta right here. It says that we've got our x, we've got our y, this is our radius. Okay, so radius, we've got our x, we've got a negative y. Now, the other thing that we know is that we can actually tell what one of our points was based on that slope that we used. So if we started at the point 0, 0, the slope says we would go down 2, we would go over 3, which would put this, say, at the point 3, negative 2. And that's going to help us out a lot with trying to do our calculations. So in this problem, again, what we would have is we would have that y is negative 2, x is 3, and then we need to find sine, cosine, and tangent. So again, we want to recall that sine of your angle is equal to y over r, which means cosine of your angle is going to be x over r. And then we have that tangent of your angle is going to be y over x. Now if you're looking or noticing, we have an x and y, but we don't have this r point. So we actually need to solve for your r. So we have again that a squared plus b squared equals c squared. My a, say, is going to be 3 squared, plus my b would be a negative 2 squared, equals, and this would be your radius squared. So I have 9 plus 4 equals my radius squared. So my radius is going to be the square root of 13. Okay. So I have all the values that I need in order to get going. My y here is negative 2. My x is 3. My radius is the square root of 13. So the first thing I have is I have sine of my angle. Sine is going to be opposite over hypotenuse. So this is going to be negative 2 over the square root of 13. And then you have to rationalize. So this ends up being negative 2 square roots of 13 all over 13. The next thing I have is I have cosine of my angle is going to be 3 over the square root of 13. And again, you need to rationalize. 3 square roots of 13 over 13. Last, we asked for the tangent. And your tangent is going to be negative 2 over 3. Now notice at no point did I ever give a decimal answer. So here, you only ever give decimal answers if you are asked for the decimal answers. If you are asked to find the exact value, then you must give the reduced fraction or radical form. Okay, let's look at another one here. Find the value and the quadrant, or a function value and a quadrant are given. Find the other 5 trigonometric functions and give exact answers. So I'm telling you that I know the sine of my angle is going to be negative 5 over 13, and I'm telling you that we're in quadrant 3. So draw your triangle. So we're in quadrant 3, so I really don't need to have big 1 and 2s. What I know about it is that I'm going to use my origin, but I'm going to extend out here into quadrant 3. I'm going to drop my horizontal down so that I have everything that I need. I've got my r, it's a negative x, and it's a negative y. In this case, I'm telling you that if this is my theta, that my sine is negative 5 over 13. So this is telling you opposite over hypotenuse. So I'm telling you that opposite, so this is negative 5, and my hypotenuse is 13. What I haven't told you is the x. So the very first thing that you have to do is you have to calculate the missing value. So here we have, again, that we need to use a squared plus b squared equals c squared and plug in what we know. We have a negative 5 squared plus b squared equals 13 squared. So when we do that, we're going to end up finding that your b term is going to be the square root of that 13 squared minus negative 5 squared, which is going to equal 12. So my x here is going to be negative 12. Once you figure that out, you can go ahead and you can list your terms. I already gave you sine, so we can start with cosine. Cosine is adjacent over hypotenuse, so this is going to be negative 12 over 13. My tangent is going to be opposite over adjacent. So negative over negative is positive, so this becomes 5 over 12. I then have my cosecant, which is the opposite of sine. So take your sine and flip its reciprocal, negative 13 over 5. I've got my secant, which is the opposite of cosine. So again, take its reciprocal and flip it, negative 13 over 12. And then my cotangent. So this ends up being 12 over 5. Now again, we're in the third quadrant, so all students take. T is down here, which means your cotangent tangent should have been positive, and they were. Alright, last, let's take a look at this example. So it says find the sines of the 6 trig function values for the given angle. So in this case, all we're looking for is the sines of the values. So I have negative 620 degrees. So the first thing we want to do is we want to go ahead and draw your coordinate plane. And we're going negative, which means we're going to start in this and we're going to go ahead and search for our sine. So if we do one full rotation, we've only gone negative 360 degrees. If we go another full rotation, it's too far. So here we actually would come around until we get to in here. And so this would be your angle. And so doing this means you're going to have your negative 620 degrees. And if you look, notice we are in quadrant 2. That's what this is, quadrant 2. So all students, so we are talking about your S. So in terms of positive, we are looking at sine and cosecant. In terms of negative, we are looking at all else. So this would be the cosine, your secant, your tangent, and your cotangent. And that is all that this problem was actually looking for, was just to see if you remembered all students take calculus. So there you have an introduction and a beginning into angles and rotations and how they relate to your 6 trig functions. Now this is a concept that is going to be carried through from or with all trig functions that you work with. So make sure that if you have any questions, you let me know. Or if you feel like you need to have any additional examples, please let me know that too, and I will gladly work them out for you. Otherwise, I hope you enjoyed. Good luck with your trig, and I will see you next time.